Hello students, today we are going with Real Numbers MCQs Part 4. Let us begin. Here is our first question for the day. Let k be a positive integer. If 3 divides k square, then 3 also divides. So to answer this question, we had learnt a basic concept. What does the statement says? Statement says that let p be a prime number. If p divides a square, then p also divides a, where a is positive integer. Therefore, here if k is a positive integer and 3 divides k square, then this 3 also divides k. Therefore, the answer is option A, k. We'll move on to the next question. Here we have 2 minus root 5a. Here this is the combination of a rational number and irrational number, where rational number is 2 and irrational number is 5. So to answer this, we'll recall the concept we had learnt. It is sum or difference of a rational number and an irrational number is always a irrational number. Therefore, the answer here is option C, an irrational number. Let us move on to the next question. Here we have HCF into LCM for the numbers 105 and 120 is. So we had solved many questions on this. What's the concept here? The concept is HCF of A, B into LCM of A, B, that is equal to A into B. That is A and B are the two given numbers. So if we apply this over here, what they have given to us? They have given the two numbers where we have to find the HCF into LCM. Therefore, here we have to multiply the given numbers 105 and 120. So 105 into 120 gives us, to simplify this one, I will go with 100 plus 5 into 120. I can do the multiplication here. 120 into 100, 5 into 120. So 120 into 100 gives me 12,000 and 120 into 5 gives me 600. Therefore, the answer is 12,000 plus 600, that is 12,600, which is the product of two given numbers 105 and 120. Also, that is the answer for the question asked, that is option A. We'll move on to the next question. Here we have a question. For some integer q, every odd integer is of the form. So here, to answer this, let us recall the basic concept. We had learned that A is equal to BQ plus R, where R is greater than or equal to 0 and which is lesser than B. So if we apply here, when we consider Q as some integer, whatever value we take for Q, the option A takes the same value. So we can't tell it will be odd integer. It can be even integer also. Next, when we look at the second option, it is q plus 1. So what happens here? If we take the odd integer, it becomes even, as well as if we take the value for q as even, the answer becomes odd. Therefore, I can eliminate the first and second option. So if you look at the third option, if we take any values for q, it is getting multiplied by 2 and 1 is added to it. Therefore, what happens here? This number becomes odd number. Okay. If we look at the option 4, we have 2q. Whatever value you take for q, it is getting multiplied by 2. Therefore, this becomes even. So clearly we can get that the answer is option C. Therefore, every odd integer is of the form 2q plus 1. Therefore, the correct answer is option C, 2q plus 1. So let us move on to the last question of today. We have a question here. The HCF of the greatest single digit prime number and the smallest odd composite number is. So first let us list out the greatest single digit prime number and the smallest odd composite number so that we can find their HCF. Now the greatest single digit prime number is 7 as well as the smallest odd composite number is 9. So here please make a note of odd composite number. They're asking the smallest odd composite number as well as greatest single digit prime number. So we have the numbers here, that is 7 and 9. Therefore, the HCF of 7 and 9 is 1 because we don't have any common factor which is present in the prime factorization of 7 and 9, where the prime factorization of 7 is 7 into 1 and prime factorization of 9 is 3 into 3. Therefore, the HCF of 7 and 9 is 1, which is option C. So students, hope you have revised the chapter real numbers. I'm coming up with the polynomials chapter from the next class. Stay tuned for more questions. Thank you.